In the vastness of the universe, we often find that our understanding is only as good as the tools we use to explore it. Recent discoveries from the James Webb Space Telescope have left scientists puzzled and questioning long-held beliefs about the cosmos. Could it be that our models are wrong, or is the universe revealing secrets we've only just begun to uncover? Join us as we delve into some of the most groundbreaking discoveries that challenge everything we thought we knew about the origins of the universe. But what revolutionary knowledge can we glean from these seemingly impossible structures? Are our long-held assumptions about the universe's origin and age still valid? Or must we reconsider the astronomical theories we've relied on for decades? The exploration of the cosmos has always been an evolving endeavor. Throughout history, revolutionary developments have reshaped our understanding of the universe. Consider, for instance, our distant ancestors' belief that Earth was the center of the universe, with all celestial bodies orbiting around it. It's clear that we can be wrong. Today, we understand that our planet is just a tiny fragment in a much larger cosmic mosaic, a picture we are still far from fully deciphering. Yet every new discovery seems to encounter significant challenges to our established ideas. Take, for example, the historical debate between Einstein and Hubble. Despite Edwin Hubble's observation that galaxies were moving away from us, Albert Einstein stubbornly held on to his idea of a static, unchanging universe. He even introduced a cosmological constant to maintain that belief. In hindsight, Einstein would go on to call this his greatest mistake, while Hubble's findings became the cornerstone of our understanding of the expanding cosmos. This cosmic expansion, according to widely accepted theories, began around 13.8 billion years ago. Rather than envisioning it as a sudden explosion into pre-existing space, it's better understood as the rapid expansion of space itself. Matter, energy, and even time emerged from an initial singularity. But how can we be so sure? By analyzing this expansion retrospectively, astronomers can calculate back to a point where the density of matter and energy becomes infinite, and all distances converge to zero. One of the strongest pieces of evidence supporting the Big Bang theory is the cosmic microwave background radiation. This relic from the universe's early days permeates all of space and is almost uniform, providing a lasting imprint of the universe's infancy. Yet, for all that has been accepted about this theory, what happens when new discoveries defy these models? For example, the prevailing cosmological consensus suggests that stars first formed 200 to 300 million years after the Big Bang, and that the first galaxies were modest in size. After all, there wasn't enough matter at the time to form large galaxies. At least that's what we thought. However, recent observations from the James Webb Telescope reveal a cosmos that doesn't seem overly concerned with our theories. Last year, Webb detected something truly unexpected: galaxies that shouldn't exist according to the current understanding. These so-called impossible galaxies have left scientists in a profound dilemma. Astrophysicist Ivo Labbé and his team at Swinburne University of Technology in Melbourne analyzed early-release images from Webb's NIRCam, focusing on a section of the sky near the Big Dipper. This region is commonly associated with the universe's dawn. Labbé's team soon realized they had made a monumental discovery. As he put it, "I run the analysis software, and it spits out two numbers: distance, 13.1 billion years, and mass, 100 billion stars. These impossibly early and massive galaxies defy the expected density of matter in the young universe. For them to exist, either the universe's matter density was 2 to 5 times higher than we believed, or galaxies formed in an entirely unfamiliar way. Either possibility demands a significant rethinking of cosmological principles. Such discoveries have sparked profound debates within the scientific community. So far, no definitive explanation has been provided, but one fact is clear. 500 to 700 million years after the Big Bang, there were already 6 massive galaxies, some as large as the Milky Way, each containing up to 100 billion stars. This revelation has led researchers to refer to these objects as universe breakers. These findings question what was once considered scientific certainty, as these early galaxies possess a mass 100 times greater than predicted by previous models. Until now, astronomers believed galaxies began as small, faint clouds of stars and dust, gradually growing in size over time. But this new evidence suggests that galaxies may not form in only this way. As a result, experts are now grappling with the deepening complexity of galaxy formation, with this puzzle likely to shape future astronomical research. Further complicating matters, the James Webb Telescope has found yet another enigma. Researchers at Scuola Normale Superiore in Pisa recently identified the oldest known galaxy, JDES GS Z13-0, which formed an estimated 290 million years after the universe's birth. Even more perplexing is the fact that it likely took only around 100 million years to grow to its observed size, challenging existing notions of galaxy formation. Instead of the faint baby galaxies we expected to find, this structure contains several 100 million solar masses of stars. How could such a massive galaxy emerge so quickly in the early universe? To add to the mystery, spectroscopic analysis of this galaxy reveals the presence of oxygen and emission lines of hydrogen. This suggests that multiple generations of massive stars had already lived and died, further accelerating the growth of this galaxy. These findings prompt even more questions. How could such a bright, massive galaxy have formed so soon after the Big Bang? Why does the spectrum show elements that indicate a history of star formation cycles? Scientists continue to seek answers, but each new discovery seems to deepen the uncertainty. However, not all of Webb's revelations have led to further confusion. Some findings offer valuable clues. One of the most significant mysteries has been the origin of light in the early universe. Approximately 380,000 years after the Big Bang, during what is known as the Dark Ages, the universe was a dense, foggy void filled with neutral hydrogen gas. Then, about 100 million years later, the first stars emerged, ionizing the hydrogen and making the universe transparent again. But where did the photons that brought light to the universe come from? For decades, theories have debated whether black holes were responsible. Thanks to Webb, the cosmic veil has been lifted, offering a clearer glimpse into this fundamental question. An international research team has recently shown that small dwarf galaxies likely produced vast amounts of high-energy radiation. These discoveries were made during the Uncover program, which utilized Webb's NIR-SPEC and NIRCam instruments. The team was able to pinpoint these faint galaxies thanks to the gravitational lens effect, where massive foreground objects distort and magnify the light from distant galaxies, making them visible. The findings show that 8 faint galaxies, typically invisible to our instruments, emit 4 times more radiation than previously thought. This leads to the exciting conclusion that these galaxies played a pivotal role in reionizing the universe. Though these galaxies themselves weren't solely responsible for ionizing the universe, their contribution was a crucial piece of the cosmic puzzle. The mysteries of the universe are far from solved, and with each new discovery, the cosmos pushes the boundaries of our knowledge. The impossible galaxies, detected by the James Webb Space Telescope, show us that the universe is more complex and awe-inspiring than we ever imagined. While these revelations leave us with more questions than answers, they also bring us closer to unlocking the true nature of our cosmic origins. Stay tuned, as the journey of discovery has only just begun.